Bonsoir à tous, bonsoir les amis. Nous nous retrouvons ce soir pour un lancement, pas de SpaceX cette fois-ci, mais bien un lancement pour la fusée New Glenn. On va suivre ensemble un moment historique. Le lancement donc de la New Glenn, c'est la fusée géante de Blue Origin. Alors pour vous présenter un petit peu cette mission, donc ce lanceur va emporter donc les sondes jumelles prénommées Escapade de la NASA pour étudier Mars depuis l'orbite martienne. C'est aussi donc l'occasion de tenter la récupération du premier étage sur une barge en mer. Donc, pour vous expliquer un petit peu New Glenn et Blue Origin, ainsi un petit peu le contexte historique. New Glenn est donc le plus gros lanceur réutilisable de Blue Origin. Il peut placer jusqu'à 45 tonnes en orbite basse. Attendez, je vais vous mettre une petite infographie après par rapport au lanceur. Alors, voilà l'infographie. Donc, je vous ai dit, il peut placer 45 tonnes en orbite basse. Donc, et le nom vient de John Glenn. C'est le premier américain qui est parti en orbite. Pour revenir à notre mission, donc la mission Escapade. Donc ce seront donc deux sondes jumelles, Blue et Gold, pour étudier le vent solaire autour de Mars. Donc vraiment une grosse mission. Donc là vraiment on se concentre vraiment sur le New Space. Blue Origin veut concurrencer SpaceX en développant en ayant développé du coup des sondes en partenariat avec la NASA pour les envoyer sur Mars afin d'étudier donc les vents martiens, les vents solaires autour de Mars. Donc une mission scientifique mais aussi un test technologique pour les fusées et la récupération du premier étage. Donc le lancement aura lieu depuis Cap Canaveral en Floride au pad SLC 36 qui a été entièrement rénové pour les futurs lancements de Blue Origin avec New Glenn. La fenêtre de lancement est à 20h50 heure de Paris. Donc, les contrôles finaux seront donc les vérifications des systèmes de propulsion, des moteurs BE4, du système de navigation. Donc, BE4, vous pouvez le voir sur l'image. L'image est bien réalisée, franchement. Comment dire, qu'est-ce que je vais dire? Bon. Ces moteurs donc BE4 peuvent soulever donc 3600 tonnes en poussée. Après, on aura une séparation du premier étage qui interviendra à peu près entre 2-3 minutes après le décollage. Puis le premier étage va tenter l'atterrissage sur une barge. Ça va être impressionnant, vraiment à suivre. Puis ensuite, on aura l'allumage du second étage. C'est lui qui va envoyer Escapade sur sa trajectoire vers Mars. Ensuite, donc, il y aura la mise en orbite et une confirmation du succès, on espère, du lancement par la société Blue Origin, tous les opérateurs, si tout se passe bien. Et donc après, Blue et Gold commenceront donc leur voyage martien. Alors, je vais regarder si vous avez des questions. Je vais regarder. N'hésitez pas à me poser des questions, hein. N'hésitez pas à mettre des likes, n'hésitez pas à poser des questions. Suivez avec nous le direct du lancement New Glenn, mission Escapade. Alors, revenons à nos moutons. Je vais vous montrer donc. Donc ça, ouais, c'est le... On a tous les boosters. Donc là, on en a 6 boosters, 6 mini boosters. Qui aident donc les moteurs BE4, le moteur BE4 à propulser le lanceur, qui sont directement accrochés au booster principal. L'interstage, donc lui, il tombe. Après, on a les moteurs, les deux moteurs RL10 qui sont reliés au Centaure. Donc ça, c'est le second étage qui lui va faire continuer l'ascension pour emmener dans leur trajectoire les satellites. Et donc les satellites vont se déployer après et continuer à suivre leur trajectoire après dans l'espace jusqu'à Mars. Alors, je vais vous mettre du coup le direct, le stream. Tac, tac, tac. À moins que j'ai d'autres. Ah, bah, je vais vous montrer un petit peu Cap Canaveral. Du coup, pour le coup, Cap Canaveral, on va aller sur la map. Voilà. Je vais essayer de vous montrer ça. C'est bon. Alors, tac, tac, tac. Oula. Donc là, voilà, on a une petite vue. Je suis désolé hein, pour le cadrage, c'est pas top top. Donc là, nous sommes à Paris. Ok. Je vais vous montrer Cap Canaveral. Moi, je vais directement chercher. Ou sinon, je peux aller directement. Je connais. Je connais l'endroit. Voilà. Donc, nous sommes en Floride, hein. Orlando. Orlando, Tituinsville et Cap Canaveral. Voilà. Donc ça, c'est vraiment tous les pâtirs. L'ensemble des pâtirs. Il y en a qui sont inactifs. Et il y en a d'autres toujours en activité. Notamment le 41. Celle-ci 41. Qui est réservé actuellement à SpaceX. SLC-40, pardon, pour SpaceX. Et celui-ci, pardon. Et l'autre, c'est pour tout ce qui est ULA. Voilà, et ça c'est pas de... Tout ça c'est la base militaire. Et nous, le SLC-34, Normalement, c'était ça que je vous ai dit tout à l'heure. Décollage depuis le SLC 34. Non, SLC 36, excusez-moi. SLC 36, il est là. Voilà, une petite image. Voilà les images. Donc ça, c'est le SLC 36. On est vraiment sur l'océan Atlantique. On est vraiment sur la côte, ce qu'ils appellent la Space Coast. Et bien sûr, après, un peu plus haut, nous avons le côté civil, avec les bases notamment super connues, le SLC 39A et 39B. 39A qui est pareil super connu là, pour les navettes spatiales, mais aussi pour la Falcon Heavy. Et le B pour les missions avec les missions lunaires. On verra prochainement pour la prochaine mission, la mission 2, la mission du Space Launch System des missions Artemis pour renvoyer les humains sur la Lune. Voilà, voilà. Voilà, on est au large des Bahamas. C'est magnifique. Allez, fini la map. Je vais vous montrer du coup le live du lancement de New Glenn. Là, nous sommes en direct. Nous sommes en direct. Il reste 46 minutes avant le lancement de la fusée New Glenn. Je mets pas le son pour l'instant parce que le live n'est pas commencé. Il est commencé de leur côté, mais c'est pas le moment forcément le plus intéressant. Donc là, on voit la condensation autour du lanceur, un peu de cryogénisation, on va dire, avec cette condensation. Effectivement, c'est très très froid. Donc ouais, comme je vous disais, par rapport au BE4, il y a 7 moteurs BE4 pour le premier étage. Ça, c'est pour le premier étage. Avec du méthane liquide au niveau du carburant et de l'oxygène liquide. Bien sûr, toujours l'oxygène liquide qui fait qui est l'oxydant. Il y a le carburant et l'oxydant. Et vous allez me dire pourquoi? Parce que le méthane, du coup, plus propre que le kérosène. Moins de suie, facilité à la réutilisation. Et une haute densité énergétique, donc ce qui fait on fait un bon compromis au niveau puissance et poids. Ensuite, le deuxième étage, donc un moteur BE3U, a quant à lui en carburant de l'hydrogène liquide, toujours avec un oxydant d'oxygène liquide. Là, vous allez me dire aussi pourquoi, car l'hydrogène est donc léger et très efficace pour les manœuvres orbitaires, vraiment pour le déplacement du lanceur, parfait pour pousser la charge utile vers Mars. Donc voilà, c'était juste pour vous donner un peu de détails donc sur le carburant. Et donc là, c'est l'hydrogène liquide avec l'oxygène liquide, tout le mélange. Et un petit peu comme une couche de glace autour du lanceur. C'est pour ça que le lanceur est bien blanc. Et il y a une condensation, notamment liée au froid. Parce que là, c'est très très froid. Pour l'instant, il fait beau là-bas, en espérant qu'il n'y ait pas trop de vent en altitude. Juste pour vous dire, je vais aller regarder au pourcentage par rapport au vent pour le Go for Lunch. Je vais vous dire ça tout de suite. Alors nous sommes à 60% Go for Lunch. Donc il peut y avoir des chances que le vol soit reporté. Donc à demain. Ou bien que le lancement ait lieu. Après tout dépend en fait des vents en altitude. C'est vraiment ça qui va jouer sur le lancement. N'hésitez pas à commenter, mettre des messages. N'hésitez pas à liker, partager la vidéo, vous abonner. Ça fera chaud au cœur. Bonjour à la personne qui a rejoint. Bonjour. Bienvenue sur le lancement de la New Glenn. Bienvenue. C'est un lancement en partenariat avec la NASA, comme je l'ai expliqué tout à l'heure. N'hésite pas à mettre un like et t'abonner. Ça fera super plaisir. Ni aussi faire un peu de pub aussi pour la chaîne. Merci beaucoup. Alors les amis, je vais augmenter un petit peu le son quand même pour voir ce que dit un peu la NASA. Je dis la NASA, Blue Origin plutôt. Bon, je ne vais pas monter le son parce que le problème c'est qu'ils mettent de la musique pour l'instant. Donc c'est un petit peu compliqué quand même. C'est un peu compliqué. Bonjour à tous ceux qui rejoignent. Bonjour à tous. Merci de rejoindre le live, ça fait super plaisir. Donc le lancement est dans 39 minutes. Est-ce que quelqu'un n'a pas suivi? Mettez un commentaire si vous n'avez pas suivi les explications. Sinon je me répète, il n'y a pas de problème. Je réexplique ce que j'ai dit tout à l'heure par rapport au lancement. Bonjour à la personne qui rejoint. Bonjour à tous. Bonsoir. Ça fait super plaisir que vous rejoigniez le live. N'hésitez pas à mettre un commentaire si vous avez des questions, si vous voulez une explication par rapport au lancement. Parce que j'ai fait une explication tout à l'heure, mais je crois qu'il n'y avait qu'une personne, la personne est partie. C'est pour ça, si vous souhaitez quand même avoir une explication, ce qui peut être important quand même, je vous la fais sans problème, il n'y a pas de problème. N'hésitez pas à mettre un message. J'ai débuté il n'y a pas très très longtemps, comment dire, la chaîne YouTube. C'est pour ça que d'ailleurs il y a que 2 abonnés, mais mais sinon ouais, c'est vraiment un plaisir. On partage un bon moment tous ensemble. C'est voilà, autour d'un lancement. Donc bienvenue à vous tous. Merci pour le j'aime, ça fait super plaisir. Merci à toi. Merci beaucoup. Je ne sais pas qui tu es, mais ça fait super plaisir. Donc là, si tu veux, je vais te réexpliquer. Donc là, on est bonjour à la personne qui rejoint. Bonjour, bonjour. Alors là, nous sommes sur un lancement de la mission Escapade, donc de Blue Origin, qui va envoyer les satellites Blue and Gold vers Mars pour explorer les vents solaires autour de Mars, qui vont aider en fait à étudier pour les prochaines missions humaines, voire bah, pour expérimenter, hein, pour pouvoir après vivre par la suite sur Mars. Ce qui ne se fera pas tout de suite, hein, mais donc là c'est vraiment le deuxième lancement de la fusée New Glenn de Blue Origin. Il n'y a que 2 satellites. Il n'y a vraiment que 2 satellites ce soir. Il y a 2 satellites et c'est opéré par la NASA et les satellites ont été fabriqués du coup par RocketLab. Tout le monde est en relation en fait. Et le lancement a lieu depuis la base de lancement de Cap Canaveral et plus précisément sur la Space Force. Donc vraiment le côté militaire, hein, pas le côté civil. Donc il y aura une possibilité qu'on n'ait pas forcément de vue sur les satellites, mais vraiment que du lancement. l'heure de lancement se rapproche. On arrive bientôt à 33 minutes. Merci à tous ceux qui rejoignent. Merci. Nous étions 4. N'hésitez pas à mettre des commentaires, poser des questions. Je répondrai à vos questions. N'hésitez pas à poser des questions. J'y répondrai. Je sais qu'on est pas mal à faire des lives sur cette mission. Franchement, c'est vraiment une mission. Moi, je la qualifie d'historique parce que c'est vraiment le deuxième lancement de la New Glenn. Et c'est vrai qu'on parle beaucoup de SpaceX. C'est pas pour faire, je vais pas faire de favoritisme pour telle ou telle société, mais on parle pas assez de Blue Origin quand même. Et Blue Origin a mis au point quand même un lanceur ultra futuriste avec ils vont essayer ce soir de réutiliser leur premier étage. Ils utilisent quand même des matériaux assez propres. Franchement, on voit aussi que le premier étage, ils utilisent du méthane liquide avec de l'oxygène liquide pour remplacer le kérosène, car le méthane est plus propre que le kérosène, donc moins de suie et facile à la réutilisation. Et notamment pour faire un bon compromis entre le rapport entre puissance et poids du lanceur. Donc ça c'est pour le premier étage, mais après le second étage, quant à lui, utilise de l'hydrogène liquide et aussi donc de l'oxygène liquide, l'ox, car l'hydrogène, lui, est léger, donc efficace pour les manœuvres orbitaires, comme pour le lancement de ce soir, pour pousser la charge utile vers Mars. C'est ça qui est pas mal. Et qui permet aussi Blue Origin de concurrencer les autres sociétés. Donc là, on voit sur les images la barge en mer. Ah bah, trop tard, c'est pas grave. Mais on voyait la barge en mer pour utiliser la tentative de réutilisation du premier étage. Donc, qui permettra en fait au premier étage d'être réutilisé pour les prochains lancements. Le second étage, lui, quant à lui, sera pas réutilisé. Il sera quand même récupéré en mer ou détruit dans le ciel, du coup, au retour. Mais ouais, le but c'est de réutiliser le premier étage. N'hésitez pas à vous abonner, n'hésitez pas à partager le live. Comme ça, vous pourrez suivre pareil, donc revoir ce lancement et suivre les prochains directs et directs de SpaceX. Je ferai des lives sur SpaceX, sur Blue Origin, aussi sur l'ESA avec les fusées Ariane et les fusées de RocketLab, de pas mal de sociétés. Bien sûr, hein, là on peut voir le plus comment dire de lancement. N'hésitez pas à actualiser, vous abonner, partager le live et lâcher un petit pouce bleu, ça fera super plaisir. Là on voit l'équipe de Blue Origin ils sont super contents pour le lancement et ils ont super hâte. On arrive bientôt à l'heure de lancement, 28 minutes. Ça s'approche, ça s'approche. Excusez-moi, hein, je regarde juste un truc. Voilà. Ah, comment ça se fait qu'on a pas de live? Ah si, c'est bon. Là, on a les images. Je vais mettre un petit fond sonore en même temps. Euh, voilà. Et que là, on a les images un petit peu de donc du pas de tir, avec les petites cheminées là pour évacuer tout le mauvais, tout ce qui est mauvais pour le lanceur, tous les gaz et tout ça qui sont mauvais. J'arrive pas à remarquer si... On dirait qu'il y a de la pluie quand même. On dirait qu'il y a de la pluie sur Cap Canaveral là. Ah oui. Ah bah voilà, la météo elle a changé. Elle a changé en peu de temps quand même, hein. En espérant qu'on n'ait pas de problème quand même, que le lancement ait lieu. Sinon ce sera reporté demain. On croise les doigts. On croise les doigts pour que le lancement ait lieu quand même. Bon, je vous laisse avec les images. On se retrouve tout à l'heure, je l'espère. Je vous laisse en live. J'ai quelque chose à aller faire rapidement. Je laisse. À tout de suite.
you and I, we're sitting here at the desk. We were looking at this beautiful image of New Glenn on the pad. But yesterday, you and I actually got to go out to the pad. We had some time to look at NG2 in all glory. And so I want to talk about how cool it was for us to go and see this engineering marvel.
Let's check it out.
Okay, so walk me through kind of the different components of this rocket.
Okay, so on the most very basic level, we've got GS1, and then stacked on top of it, GS2. It's basically like stacking a rocket on top of a rocket, right? So let's maybe start with the GS1 because it's doing a lot of the work today, right? And we want to land this booster as well. At the top, we call the forward section, you'll see kind of a gold section up there at the top where the 4 fins are.
Right.
Those fins, they move back and forth, right? So they help with directional capability on the rocket. The whole main section of it, though, in the middle, is basically a big fuel tank. And then you get to the aft, the bottom section there, that has the landing gear you see in each of the doors, but it also has the 7 BE4 engines that are in the base.
Right.
At the top, then, so that's basically GS1. At the top, basically from the white portion above the gold and beyond, tucked in there are the 2 BE3U engines. The part with the feather, again, that's all basically tank, liquid oxygen, liquid hydrogen for the propellants. I forgot to mention liquid oxygen and liquefied natural gas, the propellants for the first stage, so they're different propellants. And then kind of that nice, smooth top, that is the fairing. There are 2 halves of the fairing, and those will deploy off, those will fall apart once the second stage is up in space.
Right.
And inside the fairing is where the Escapade, the 2 payloads, the 2 satellites of the Escapade mission are currently.
Our twins.
They're twins. They're on what's called an ESPA ring. And so it's a ring that mates to the top of the rocket. And then on that ESPA ring, we put the 2 satellites. So once they're up there in orbit at about 33 minutes, first the blue will deploy. We wait 30 seconds. Pretty obvious. We don't want them to run into each other, right? And then second, the gold deploys. So that's what happens with the second stage once it's off of space. But keep in mind, first stage,
making its way home.
It's making its way home, right? So the engines have done half of the work on its way up. We flip it around. We start a burn that slows the rocket.
Right.
We then use the strakes, or they're basically our wings at the base of the rocket. It helps with what we call cross range. So we basically can effectively fly the rocket, and then it lands on the Jacqueline platform just in the last couple minutes or less even. We have 3 of the 7 engines that relight, and then finally just the final engine that lights. You don't need all of the power, all the engines, because you're landing what is effectively an empty fuel tank.
And something the size of a skyscraper.
Something that's the size of a skyscraper. So you do need power, obviously, but not as much, obviously, as when it starts. And then it should come for a nice soft landing on the Jacqueline. And if we do that,
it'll be pretty epic.
It'll be history, it'll be epic, and it opens a new chapter for Blue Origin.
So appropriately named, Never Tell Me the Odds.
Don't tell me those odds.
And Ariane, it was really, I don't know, almost like an out-of-body experience to be standing next to New Glenn. I have been to New Shepard launches. This is my first New Glenn launch. And to see New Glenn upright, and to be in the presence of something the size of a skyscraper, and to learn, as you mentioned, it's essentially a rocket stacked on top of a rocket, right? And the pad itself has so much history. It's just like, I don't know, Space Coast is such a special place. This launch is so special. This rocket is so special. So
yeah, I had a chance to chat with some of our customers and our VIPs that also got a chance to check out the rocket. A lot of them, of course, have been in the industry a long time, and they got out there for a photo op yesterday, and they said, "This rocket just looks beautiful." Yeah. And there is something to be said, actually, for you can look at a piece of engineering. I know it's very simplistic, but you can look at a piece of engineering and be like, aha, that looks right. That looks right, it feels right. You add too many bells and whistles and you're like, it's not. This rocket is a marvel of engineering. It flew so well on its first go. I cannot wait to see how it performs on its second go. And as we said, we're cautiously optimistic. We've made some changes to the first stage after our first launch, where we didn't recover the booster to be able to land this time. And we feel good. We feel good. I don't want to jinx anything, but man, I feel
We're
good.
knocking. I knock on my, yeah.
Knocking all over the place, yeah.
But you're right. I've been talking to employees, for months leading up to this moment, and employees do feel good. Engineers feel good. And this launch, it feels different. It feels good. And I think everyone is just, on the edge of their seat at this precipice, right? We're ready to land the booster.
It would feel a lot better if these clouds got out of the way, if this weather got out of the way.
We are in a weather hold. So here's what's going on. If you are tuning in right now, you're watching the webcast for NG2. You might notice on your screen that we are in a hold. We're doing that to allow for a little more time for that weather to clear. We're gonna let you know and keep you guys posted on the new T clock as soon as we get information on that. So right now, let's toss it back over to New Glenn on the pad as we wait for some of this weather to just kind of move on out.
Roll on by.
Let's get out of here. friends, you are watching the webcast of NG2. We are currently in a hold at about L-20 minutes. But in the meantime, here's something we love to do here. We love our jobs here, and we also love inspiring others. We want to inspire a few more of you also at home with our nonprofit Club for the Future. Club has the mission to inspire and mobilize future generations to pursue careers in STEAM. That's science, technology, engineering, arts, and math, all for the benefit of Earth. I am the A in STEAM.
Yeah,
Which is the arts part.
Which is super, super important. The ability to communicate about it, right? Like it's so important, the A component of STEAM. But as part of the Club for the Future program, one of the cool opportunities that we give is we allow students to send postcards to space and back via New Shepard, and we also provide online STEAM-based lesson plans that are free for students and teachers to use. And then so that everybody can get a piece of the action.
That's right.
Even easier is that we have these digital postcard, this drawing tool that you can go online, and anybody can send that art to space. So for more information, if that sounds cool to you, just go to clubforfuture.org.
That's right. That's clubforfuture.org. Ariane, where do you fall in the STEAM spectrum? You're a bit of everything, I feel like.
I've always kind of been like...
You're like, I'm science and technology and a bit of engineering and math.
Yeah, but I kind of like it all.
Yeah. And arts today and anytime we get the honor of having you with us.
Let's be very clear. I'm not the one that's going to be designing that insane trajectory that Advanced Space did for Escapade today. Right. So, like, props to you guys. But I love every part of space and all that goes into it, and clearly the A part of it is also incredibly important.
It's neat to have such a cool team of all of the great letters that work together. And Jeff himself has said that it is this generation's job to build a road to space so that future generations can unleash their creativity. Check it out.
When I was in high school, I was working to build a rocket for a target altitude competition.
My mom took me to an observatory opening, and I got to see the rings of Saturn through a telescope.
Growing up, I was just not very good at doing school. I wasn't really good at doing homework.
There was a teacher at my school, Mr. Cullen, and we spent hours together after school. I would be building a rocket in the back of his class, and that was incredible for me.
I had a chemistry teacher who also taught astronomy, sparked that interest in me. She went outside the lines of what I believed a science person should be.
It helped jumpstart a passion where I am now a propulsion engineer launching rockets.
If a teacher like that could help a student like me and pull me to this career, it just makes me think, you know, what can I do to help inspire the next generation?
And that was life-changing for me.
And that's what Club for the Future is really all about.
At Club for the Future, our mission is clear: to inspire and mobilize future generations to pursue careers in STEAM, science, technology, engineering, arts, and math, and all for the benefit of Earth.
We're here to create meaningful experiences that spark curiosity and ignite passion.
We're teaming up with educators to make learning an adventure by creating space-based lessons for K-12 students.
If we want to see millions of people living and working in space, space should look like all the populations of Earth.
Our goal is to make learning about space more accessible for all. So we've joined with others to reach underrepresented students and underserved communities.
But it's not just about what happens in your classroom. As Blue Origin's Club ambassadors, we're here to share our expertise and inspire students through speaking opportunities, events, and mentorship.
Also, with our Postcards to Space program, kids can connect with the vastness of space and the future of our planet.
Draw your vision of the future or write any message you want on a postcard and we'll launch it to space and back on a New Shepard rocket.
Your postcard will be stamped, flown to space, and returned to you as a unique keepsake.
So let's go. Let's dream big, reach high, and build a future where the possibilities, they're as endless as the stars.
Love Club for the Future, and you saw those really excited employees out there.
Yeah.
There they are, losing it. That's right. Team Blue. Looks like, I think this is our team in Huntsville. There's our team in Kent. Coming in on a Sunday to cheer on their rocket. Woo! You see,
I want to cheer with them. I want to be there.
If we land this rocket today, they're gonna
go nuts.
This is cheering.
We may not ever be able to show it.
There's a team out here in Florida. You see, they're on top of the garage just right next to us. They've got the best view for this launch. There's our team. They are ready to rock and roll. I love it. I absolutely love it. The team at Blue.
There they go.
You're on TV. Let's go.
We're waiting too. We understand. We're waiting on that weather hole to lift. Everyone's excited, but the time is coming.
Where our team is they're still working on the situation with the weather and assessing the weather conditions out there, but otherwise speaking, the team and the rocket are ready to go. Looks beautiful.
Yeah.
Looks beautiful.
And I think what you were saying is, employees are so excited, and they're also very involved in community, and they're involved in schools, and Club for the Future gives us that opportunity.
Yeah, and it's not an accident in the sense that, our vision is millions of people living and working in space for the benefit of Earth.
That's right.
Right?
For all of Earth.
For all of Earth. And we need to, 3 steps to that. We got to reduce the cost of accessing space.
Number 1.
We need to figure out then how to go to space and take advantage of the resources that are out there to make life on Earth better. And the third key part of that is inspiring the next generation, because this is not a project that is done in 6 months. This is not building an app, right? Like this is
forever.
Decadal, generational type of work. And if we don't have a strong next generation to pass the baton to, that is super excited and is trained and is motivated to do so, then what are we doing?
Knowledge is power.
It fades if you don't pass that baton on. And so that's why at Blue we've made it a core part of what we do. And I don't use like the big, we Blue Origin, but literally as individuals, there are so many of us that we call club ambassadors that go
I'm one of them.
I'm
You're
also
one of them.
Go and speak about space on behalf of Blue, but arguably on behalf of the industry, because that is such a critical component of what we do. So props to the actual group within Blue Origin, our Club for the Future team.
Heather and Lucas and Kristen, they love to reach out, and we love to help them out anytime. Recently, I even had the opportunity to speak to a group of students in India.
Oh, I love it.
I had just gone to India last year, and the fact I was able then to turn around and talk to them and relate not only my travels to India to what we're doing in the space industry here and what we're doing at Blue, I mean, it really brings a tear to my eye, because it's so cool to be able to make those connections. So you could tell we love Club for the Future. We love inspiring the next generation, and we love inspiring you too at home. But if you're just joining us, this is the webcast for NG2. We've got a live look on the right side of your screen of Jacqueline. Would look a lot better once that booster goes up, and we maybe set it down right where that feather is. Looks like a good spot right there. And then, of course, on the left-hand side, you have New Glenn on the pad ready to go. But let's talk about the flight profile overall. While we're in this hold, we're in a weather hold right now, we made a really cool video that dives a little bit deeper on the entire flight profile of New Glenn. So check it out.
New Glenn lifts off from Launch Complex 36 on Cape Canaveral. 7 BE-4 engines will ignite and propel the rocket upward with over 3.8 million pounds of thrust, or roughly 17,000 kilonewtons. The vehicle will quickly reach supersonic speeds as it climbs through the atmosphere. As the rocket ascends, it will encounter maximum aerodynamic pressure, known as max Q, at around 40,000 feet, or 12 kilometers. This is the point at which the stress on the vehicle is at its highest. Around 3 minutes into the flight, the vehicle will turn off its engines, marking the end of the boost phase. Shortly after, the reusable first stage will separate and begin its journey back to Earth. 2 BE-3U engines on the second stage will ignite and propel it onward into orbit with the payload. The reusable booster reorients in the vacuum of space using its reaction control system. At 220,000 feet, or 67 kilometers, it executes an exo-atmospheric deceleration burn using its center 3 engines. These engines gimbal for maximum control of the booster. This burn slows the vehicle down before re-entering the atmosphere. As it descends, the booster's strakes and fins work together to slow it down and guide it autonomously back to Earth, landing on a vessel at sea. At around 9,000 feet, or just under 3,000 meters, the first stage begins its final landing burn. The 3 middle engines will light for 20 seconds, slowing the vehicle in preparation for the final descent. The 2 outer engines will turn off, and the center engine will execute the final controlled maneuver onto the landing platform. The vessel will return to Cape Canaveral to prepare for its next mission. Meanwhile, in space, the second stage will continue to power the payload towards its final orbit. At around 400,000 feet, or 120 kilometers, the payload fairings will jettison. New Glenn will deliver an unprecedented range of payloads. Large satellites, dual payloads, orbital vehicles, large constellation dispensers, even moonlanders destined to establish permanent human presence on the moon. Once it arrives at its insertion location, the payload will separate from New Glenn's second stage. This is New Glenn. This is how we will build a road to space.
I get chills every time I see that feather come on screen. It's such a great piece pulled together to really explain what's going to be happening with NG2. So there you go. You have a live look, though, of New Glenn on the pad. Now you understand the entire flight profile. But while we're in this hold and we're working out weather, let's go ahead and send it back over to the rocket and just sit with NG2. friends, you are watching the webcast for NG2. We are currently in a hold at about the L-20-minute mark. And I got an update for you guys. We're waiting on weather. You might be looking at that and be like, the weather looks pretty good, Tabitha. And I'd be like, you're right. It's looking a lot better, huh? Well, we're also chasing some boats out of the way.
The boats!
There are some boats that are essentially being told, hey, you're in our flight path. You got to get out of here. They should have known that to begin with, but that's just one of the other things that you deal with when you deal with rocket launches.
Tabitha, I'm gonna try to see the silver lining in this, or I'm gonna try to be the ever optimist that I am. Last time we had this launch, we also had an errant boat in our in our flight path. And we had a pretty spectacular launch, and we put our payload, got to orbit, we filled our objective. So I'm gonna call this a good luck omen.
A good luck. You know, speaking of good luck omens, yesterday, me, you, and our very own Eddie Safert, we were headed out to the launch pad, and we saw a tortoise crossing the road. And if you didn't know, tortoises are a part of our coat of arms, and we find them as a sign of good luck. So Eddie, you are out there, you are with employees, you're at the best spot to see the rocket launch. But let's talk about something serious for a second. Let's talk about how hard it is to land the booster. For those of you who don't know, you probably do know if you're watching this webcast, on our first attempt, we weren't able to land the booster, but we were able to get our payload into orbit. Today, our big objective, aside from getting our payload into orbit, which is Escapade, is we want to land our booster. No, never tell me the odds, and I like the name of that booster, so I want to keep it. So Eddie, how hard is that?
Well, so first off, thank you for your patience. The weather here is looking a little better. The boats, as Ariane said last time, definitely safety is our highest priority. And the tortoise, for me, a sign of good luck. I mean, I think it's just a trifecta of signs that we're ready to not just launch Escapade to space successfully, but to land this booster. So we learned a lot. Nothing substitutes flight data. So the GS1 booster, after it separates from the GS2 upper stage, it does a 180-degree flip maneuver so that the aft section is facing backwards, or basically back down to Earth, but in the flight path. And so that 180-degree maneuver is conducted by our reaction control system. They're peroxide monothrusters. We call them the severe weather agility thrusters. And those worked perfectly last time. We did the maneuver. And then the BE4 engine goes for reignition. So the 3 center engines reignite what we call the exo-atmospheric re-entry burn. And its entire purpose is to slow down the GS1 as it re-enters the atmosphere so that its superior aerodynamic performance, those long strakes, those forward fins, can guide the GS1 booster over the Jacqueline.
Yeah, Eddie, thank you for such a good explanation for our viewers at home, because it took a little bit for me to understand too exactly. I'm like, why is it so difficult? And it's like,
yeah, it's hard.
It's pretty difficult. And I'm like, yeah, it's like when you watch the Olympics and you watch someone run fast, you're like, oh, I can do that. It's like, no, you can't. It's actually quite difficult. So thank you, Eddie, for that great explanation. Again, we are currently in a hold. You are watching NG2, our webcast here. We are at about L-20 minutes. We're going to toss it right back over to the rocket. New Glenn is on the pad. It is feeling cool. It is looking cool. And it is literally, Ariane, very cool right now. right, friends, you are watching the webcast for NG2 right now. You can see New Glenn out there on the pad. But an important part of what's happening today with New Glenn is we are sending Escapade to Mars. And I got the extreme privilege, the honor, if you will, to talk to the principal investigator of Escapade, Dr. Rob Lillis. Check it out. Rob, for someone who doesn't know, what does the principal investigator of Escapade do?
So the principal investigator is entrusted by NASA to execute the entire project. So it's kind of like the buck stops with me. I have a team of excellent people around me, but I'm responsible for the production of the data, the definition of the science requirements, the execution, the technical aspect of the mission. I think it's a great model for how NASA sort of entrusts the completion, execution of a mission to a partner like UC Berkeley, where I'm based.
And Escapade is a really special project. We are so excited to be taking it up today on NG2. Tell me a little bit about what Escapade does.
So Escapade is a twin spacecraft mission going to Mars, orbiting Mars to sample the ways in which Mars and its upper atmosphere respond to changes in space weather. By space weather, I mean the million-mile-per-hour stream of charged particles that the sun is at all times throwing out. Sometimes that stream gets gusty, and the gustiness, essentially, of it is what we call space weather. And there's all sorts of ways that can happen. The magnetic field can get stronger, the speed can get higher, the density can get higher, and all those things have an effect on the Martian atmosphere. And over time, it can strip away the particles in the upper atmosphere. And we know that this has been an important process by which Mars's climate has changed over Martian history. Early in Mars history, up to about 2 billion years ago, Mars was at least occasionally warm and wet. It had a thick atmosphere. It was habitable. We don't know whether life actually existed, but it was habitable there. But then in the last 2 billion years, it's lost most of its atmosphere. And we think that the stripping of the atmosphere by the solar wind is a big reason why that happened. And Escapade is going to be sampling and investigating these processes with a stereo perspective with 2 spacecraft. And that's really important, because up until now, with one single spacecraft, we've only been able to measure either the solar wind itself or the effect of the solar wind closer to the planet. We've either had the cause or the effect, but separately. With Escapade, we can have 2 spacecraft simultaneously cause and effect at the same time. And so that's the breakthrough that Escapade is going to provide us in understanding the processes by which the atmosphere is stripped away.
And once we understand that, I mean, how does that affect us here back on Earth or future Mars missions?
Right, so it's important for a couple of reasons. One, I think we're just curious as to how planets evolve in general. Like, over the billions of years, planets, they change their atmospheric composition, they're more volcanically active, and that can affect the atmosphere too. And so this is an important piece, isn't the only piece, of course, but it's an important piece of the puzzle of Mars climate evolution. And that's interesting just because we love to explore as humans. But it's also important because space weather can have a practical effect on robotic spacecraft that we send to Mars future, and also humans when they explore Mars. This is important for a couple of different reasons. One, a big space weather event, what's often called an interplanetary shock or a coronal mass ejection, when the sun belches out a couple billion tons of hot plasma, often at high speed, high density. As that shock expands through the solar system, it accelerates particles to really high energies. High enough energies that they can go right through a spacesuit and cause astronaut health problems.
Right.
And so the radiation on the surface of Mars, when you get a big enough coronal mass ejection, you can get 100 days worth of radiation in one day. This happened last year.
Wow.
This happened last year, June 6th, 2024. The usual background level of radiation was increased by a factor of 100 for that day when that happened. And so if you're an astronaut on the surface of Mars, you don't want to be out away from your radiation shelter when that happens. And so Escapade's measurements are going to enable us to better forecast those radiation hazards. There's another reason too why Escapade's important, because we're also going to be studying the ionosphere. So this is a layer of gas in the upper atmosphere that's ionized. And that's important because that layer, it distorts radio signals as they pass through it. And understanding the variability and the structure of that ionosphere will help us to correct for those distortions.
For communication.
Communication, but also for navigation, because there's going to want to be GPS on Mars eventually. And understanding how the ionosphere distorts the GPS signals will enable astronauts to know better where they are. All these things are taken into account on Earth. It's all behind the scenes. So your phone doesn't have to show you how they're correcting for it, but That's all behind the scenes on Earth. We want to be able to do that same error correction on Mars, and Escapade will help us understand the ionosphere.
It's really cool to know that we're thinking about these future problems now. And speaking of things that are happening in the future, I mean, Escapade is not going to be making it actually to Mars. The spacecrafts aren't going to be there for at least 2027.
That's right indeed, yeah.
So what happens once Escapade deploys? Kind of tell me more about the trajectory.
Okay, well, so after it deploys, first of all, there's a few important checkouts we have to do. The first thing is we got to deploy the solar panels, and we got to get it to speak to us. And so actually, the viewers will be interested to know that we may not hear from the spacecraft for up to 3 hours after launch. And that is by design.
Okay.
Because we have 2 antennas, one on either side of the spacecraft, and they only work one at a time. And we don't know which one necessarily is going to be pointed towards Earth initially. So if the one that turns on first happens to be pointed away from Earth, we got to wait 2 hours until it decides, oh, I'm not hearing from Earth, and it switches over to the other one. So no one should panic if we don't hear from it within that first hour. But once we know that we have signal, we're hearing from it, and we know the solar panels are deployed and they're facing the sun, so that's called power positive, so it's a safe and a stable mode, then we can relax, and then we can start focusing on the longer term aspects of the mission. And you mentioned trajectory, so yes, we are taking quite an unusual path to Mars. We are going to spend about a year in a very large Earth orbit, fairly gravitationally bound to the Earth. We're calling this the loitering phase. It's in the shape of a kidney bean. It kind of goes like this. And next November 2026, we're going to come back to Earth after going more than 2 million miles away. We're going to come back to only 600 kilometers above the surface. We're going to use Earth's gravity and burn our engines at that point, taking advantage of Earth's gravity to slingshot ourselves toward Mars. Because early November next year is when the interplanetary window opens for a transit from Earth to Mars. So all Mars missions before us have had to wait until this narrow 3 or 4 week window every 25 months. We're launching halfway between these two windows, so we're just going to kind of hang out in near Earth space until it's time to go to Mars. And this has never been done before. And this is really, really exciting because this actually opens up the possibility in the future. If humans want to actually settle Mars, we're going to have to send hundreds, maybe even thousands of ships to Mars within that 2 or 3 or 4 week window. And there aren't enough launch pads on Earth to reliably do that just within that window. So we could launch them over the course of a whole year, maybe, and we could like sort of queue them up, so that they're kind of lined up so they can go when that window opens. And so this is hopefully going to pioneer a way to essentially enable interplanetary settlement in the distant future. Who knows?
And once the mission actually starts, how long is the mission going to be going on?
So I mentioned November 2026. That's when we start our interplanetary cruise. We spend 10 months in that cruise to Mars, doing little trajectory correction maneuvers all the time, little tiny engine burns to like just barely tweak our path, so that we can intercept Mars in early September 2027. And that's when we got to do another big engine burn to be captured by Mars's gravity, and that's when we will be in Mars orbit. Then we spend another 7-8 months-ish adjusting the orbits.
Wow.
So first of all, lowering the orbits and adjusting the orbits. And this is important because Escapade is doing another thing that's never been done before, which is the first ever formation flying around another planet, other than the Earth or
a lot of firsts on this
the
one.
Moon. It's kind of like pearls on a string. Both spacecraft have to get into the same orbit. And it takes a while to adjust both orbits to make that happen. And also in the middle of that, there's what we call solar conjunction, where the sun gets in the way between Earth and Mars, and we can't talk to it for a whole month. So we kind of just have to chill out, go into safe mode, and just wait. And so this is the reason why it's going to take us an additional 7 months after we get to Mars before we can start the science mission in spring 2028. And then we have an 11-month science mission, and that's also in...
So this is going to take us all the way into 2029.
Yes, exactly, yeah. It's, I think, May 2029 is the nominal end of the science mission. And I mentioned the 2 spacecraft are going to be the pearls on a string. We do that for the first 6 months. And that's important because we want to know how the upper atmosphere of Mars is changing minute to minute. So in the past, with only single orbiter missions, we've had to wait 4 or 5 hours to see how things have changed. And by that point, the planet's turned a quarter rotation, things are different. We don't know how anything changes on short timescales at all on Mars. Escapade is going to pass through the same part of the upper atmosphere twice in a quick succession, so 2 minutes to 30 minutes apart, to see how it changes on those short timescales. Once we're done with that, then we raise one orbit, we lower the other orbit, and then the two orbits are different, and they start precessing. This is a word for the orbital planes moving with respect to each other.
Okay.
And this allows the two spacecraft to get much further apart from each other to make those simultaneous cause and effect measurements that I mentioned earlier, to understand the real-time response of the upper atmosphere to the space weather events.
And so, with all that, understanding how Escapade works, and knowing that this mission is going into 2029, how do you feel today?
I feel excited. I feel a little anxious, as everyone does on launch day, but I am super, super excited. I'm proud of everyone who worked on Escapade, at Blue Origin, at RocketLab, at Berkeley, at Embry-Riddle, all of our partners. Advanced Space LLC, they were the ones who did most of the work to design this innovative path to Mars as well. And so I'm just so proud of the whole team. Probably thousands of people have worked on bits of it up to this point. And we're so excited to reach this day, the culmination of so much effort and the beginning of the next chapter.
And the last question I have for you is something I ask everyone, and that is there anything else you want to add or say or mention I didn't ask about that you think is important to this interview?
So Escapade is a very low-cost mission. Escapade is only about 1/10 of the typical cost of a NASA planetary mission. This is a radical experiment by NASA in seeing whether they can accept slightly higher risk and less oversight in exchange for a much lower cost. And the idea being that overall you get way more science per dollar if you do this. And
we call it bang for your buck.
Bang for your buck, science for your dollar, and it's because we are embracing, as I said, a lighter sort of a touch by NASA. We're using more commercial off-the-shelf parts. There are fewer reviews. There are fewer sort of requirements. NASA's kind of letting us run a little more than they would typically. And NASA's oversight is often what drives a lot of cost. That's great, but it does come at a cost. And so this is hopefully a new way of doing at least a fraction of NASA's science portfolio with this higher risk, lower cost approach.
It's very exciting to have you here, to be able to interview you.
This is an exceptional sight. Just watching pieces of other rockets being put together, and knowing that our booster, our upper stage,
it was all built right here.
It was all built right here. The fairings, the payload adapter, it was all built right here. Yeah.
Well, Rob, thank you so much. I appreciate your time.
Cheers. Bye-bye.
So obviously a great interview and a great opportunity to be able to talk to Dr. Rob Lillis there. If you were just joining us, you are watching the webcast for NG2. If you're looking at your screen, you might notice we have a new L time, which is L minus 28 minutes and about 30 seconds. Now, to keep you guys updated, we know that the weather is now clear. You're like, all right, that's some good news, right? Well, we have also learned that the launch team is looking into an issue with our ground support equipment at the pad. So we wanted to give you an update on that. And of course, we're going to keep monitoring everything happening around NG2.
Yeah, I think a lot of people, when you look at a rocket, you're like, oh, the rocket's going to go. There is a lot of engineering that also goes into the ground systems. That's
absolutely
the pad. That is the ground systems for the telemetry and the communications. We need to be tracking the vehicle. But like out there on the pad, that pad actually is a feat of engineering in its own right. In fact, this Launch Complex 36, we were talking about it earlier in the webcast, it's been used as a launch complex for decades before us. But we
Great history,
but we basically cleared it out and built it back up again. The amount of power, data, propellants, all these lines that are going up there. You see the two towers, the one on the right will eventually have crew coming off of it. Slightly off the shot to the left, we've got the water tower. There you got a kind of a back out view so you can see a little bit more. There's a lot that goes on out there. We've got this huge, what we call our propellant farm. There's a lot that goes on out there. So we need that to also be working and working properly and in right conditions to keep the rocket ready to go as it ticks down. And then when we will turn, obviously, the show, if you will, over to the rocket. But in the meantime, there's a lot of work happening in the ground system. So if something is out of line, pressure, data, power, that then could translate down the line,
right?
Down the pipes, literally, to the rocket, we have to check it out. So our team is on it, but we do have a little bit of time here to do so. But it looks like the weather might be clearing up. You live here in Florida. This is wild. How do you put up with this?
Minutes. It just keeps on a constant rotation. But I will say, it is great to see NG2 on the pad, ready to go. You know what they say, if it's going to happen, it's going to happen out there. And so right now, I'm going to toss it back over. Again, you are watching the webcast of NG2. We're at L minus 26 minutes before this historic launch.
Les amis, je suis de retour, je suis désolé pour l'attente, c'était un petit peu long. Du coup, le lancement, comme je vous avais dit qu'il y allait avoir un hold, le timing a repris il y a quelques minutes, donc nous allons pouvoir très certainement voir le lancement. Je vais regarder le pourcentage pour le go for launch. Alors c'est parti, je regarde. Donc 22 minutes. On est toujours à 60% de go for launch. Et la fenêtre de tir va jusqu'à 22h13. Et le lancement est donc prévu maintenant à 22h12. Je pense que là, ça va être la dernière opportunité pour ce soir.
Well, if you take a look on your screen, we're at L minus just under 24 minutes. And Ariane, you and I have the distinct pleasure of being joined today by our very own Eddie Seyfert. And Eddie is one of my favorite people to... He knows all things engines, as do you. Engines with Eddie, we're coming to you. Let's talk a little bit about our engines.
Hey Tabitha, hey Ariane, thank you for the opportunity
Donc,
to talk about our rocket engines, the liquid propulsion systems.
Il y a les civils qui peuvent regarder donc ce lancement depuis le Kennedy Space Center Visitor Complex.
And in Huntsville, Alabama, they're tested at Launch Site 1 at our BE4 engine test stand, as well as at the historic 4670 test stand. Now, I'm a former test guy.
Les Américains sont à fond derrière, derrière ce type de lancement. C'est vraiment important pour eux. Donc là, nous sommes à témoin 22 minutes avant le tir de la fusée.
Eddie, do you feel like you have a particular love for one or the other, the BE4 or the BE3? I know you were out in West Texas for a long time. We do a testing of all of our engines really there, but do you have a favorite?
Well, no, it's impossible to have a favorite, right? They're all great engines. For example,
you can't say you love one of your babies more than the other, huh, Eddie?
No. Well, they're all great engines, right? BE3U, which runs on liquid oxygen, liquid hydrogen, is an open expander cycle, right? Those two molecules come together and they create a lot of energy and steam. And BE3U originally started from the BE3 engine that now has flown 30 big successful times on New Shepard, but they baselined it at 160,000 pounds of thrust. When it first flew earlier this year in January, it flew at 174,000 pounds of thrust. And this team is kicking butt. They keep increasing those thrust levels, keeping the performance high, and really it's all about the upper stage when it comes to the payload.
And you see they're actually on the shot, we've got the two nozzles in the second stage of the BE3U. Those are huge nozzles. Eddie, do you want to talk about why those nozzles are so large on the BE3Us? Why do we have to have such massive nozzles?
Right, so in the vacuum of space, these nozzles don't have the atmosphere to push back in them and crumple them when the exhaust is being exhausted at supersonic, so faster than the speed of sound velocities. And that extra nozzle just gives you more momentum and higher specific impulse, right? 30 to 40 seconds more specific impulse, right? The analogy I like to use is if I had a big red balloon here in front of me, it would have pressure inside of it as a chamber, like a pressure vessel, and I would be holding it by its nozzle. It's a very technical term. And if I let it go, the big red balloon would essentially fly away. So I'm not saying our rocket engines are big red balloons, but it's the analogy that I like to think of.
That's a good way.
At least they're blue balloons.
Yeah.
They're going to be balloons,
They
Eddie.
don't have to be red. They've been big blue balloons. He also, I remember I went to one of his, he hosts these things here at Blue Origin where we can learn more about updates with different things happening with our engines. And he was explaining essentially the shower head method and how shower head is very similar to how an engine works. But Eddie, I think it's so
20
great to be able
minutes
to talk to
avant
him
le
anytime about
lancement.
engines. And we're so grateful for him. Of course, he is out with our employees. The best viewing spot to see NG2 take to the skies. You're looking at NG2 right now on the pad, and in this moment, we're going to toss it back over to the rocket because coming up here shortly, we have a very exciting go, no go poll. So we're going to toss it over the rocket and kind of await that poll.
En espérant que le lancement aura lieu. On espère. Donc là, ils sont en train de faire un petit peu les go no go.
LC1 is no go pending. They have launched PDI load.
Understand you already go pending the load. LC2.
LC2 is go.
LSO.
Go.
OSM.
Go with the exception of weather.
RC. Go. ESR.
ESR go pending LVHT and PDI.
AC.
Go pending LVHT retraction.
Recovery.
Go.
DLI.
Go.
BMD.
Go.
GC, LC1, LC2. Perform final configurations for terminal count. Report when ready for terminal count gate checks.
LC2 go. Oh, this is RC and com 1.
Go ahead. RC.
A lot of potential sea surveillance violation with a cruise ship, but we're still working on Coast Guard to make contact. I'll give you an update as soon as I have.
LD copies.
So you just heard the go pulled there. It seems like a conditional go according to the weather. So we are going to continue to our terminal count, and we're going to continue to also keep an eye on the weather. So lots of things that we are tracking at this moment in time.
I think we should note there just a second. So first of all, our launch director, Megan Lewis, that lady is a boss.
Yes.
She is fantastic. There's a lot of things to coordinate there, and you heard various teams giving their go, no go, and go pending. And obviously we have to track a lot, especially in these last 15 minutes, and her job in that room is to coordinate.
Nous sommes à 14 minutes avant le tir de la fusée New Glenn.
In the back, so that they go off and they track, they run things down and report back on making these clears. So they are go pending because they want to launch this rocket, and they think that there's still a chance here. So
Croise les doigts quand même.
more drama.
Yeah, we're excited.
Le
This has been
lancement
quite
lieu.
the show. As you are watching in G2, we're at L-14 minutes, but in order to build a road to space for the benefit of Earth, we've got to radically reduce the cost of access to space by having our reusable rockets. So here's everything that you need to know about New Glenn.
Capability, the payload volume of New Glenn was all developed not only for today, but for the future. We have a first stage that is designed from the ground up to be operationally reusable. We have a second stage that
On a
is
les
one of the
images
largest
du
upper
premier
flight
lancement de la fusée New Glenn.
Being a reusable launch vehicle is so beneficial to future lunar missions. It's going to allow us to keep that cadence going, where we'll be able to launch multiple landers, multiple refueling flights over and over again, so that we can reduce the cost of access to the moon.
It is designed to be an incredibly resilient vehicle with a tremendous amount of mass to orbit capability.
On a tous les ingénieurs responsables de l'ingénierie de chez Blue Origin qui expliquent un petit peu
We can do very large modules of future
leur
commercial
projet.
space stations on a single launch. We can take dozens and up to 50 to 100 satellites per New Glenn mission. It is our avenue to significantly reduce the cost of access to space.
We've been working with a huge variety of customers, and they're really rethinking their business models because of what New Glenn unlocks for them.
New Glenn will be able to launch a lander to the moon in a single launch. That's an incredible capability that this one launch vehicle will be able to do. We built these landers specifically to fly with New Glenn, and that's what's so great about having the launch vehicle and the landers all part of Blue Origin, is that we work together.
It really is the infrastructure, the building block, the foundation of how Blue Origin will enable building a road to space.
We've got a number of
La séparation des coiffes, tout est modélisé.
national security customers and other customers
Déploiement des panneaux solaires pour les satellites.
course, with our own internal teams to deliver new capabilities that Blue is bringing. But New Glenn is going to be delivering all kinds of spacecraft today, all kinds of new systems, all kinds of capabilities. And New Glenn is the vehicle that can take NASA or anyone anywhere in the solar system.
We foundationally developed New Glenn for what we think space is going to look like 50 to 100 years from now.
It will allow us to go to the moon, to asteroids and other planetary objects, and use those resources to learn how to live off the land in space.
New Glenn is going to unlock so much potential that we don't even know about yet. Laying that infrastructure
C'est
so that the
magnifique.
next
Franchement,
generation can do amazing things in
le
space.
lancement est magnifique. 10 minutes avant le lancement de la fusée de Blue Origin, Blue New Glenn.
And Tabitha, you recently had the chance to chat with our CEO, Dave Limp, about NG2 and what this mission means for science, but also for Blue Origin.
I certainly did. It was so great to be able to sit down and actually talk with him. And I think you guys are going to be surprised to learn just how much of this moment has really been building up over time, and how even when he was a child, you know, Dave himself had an interest in space. Check it out.
Désolé, je vous ai mis une petite musique, mais ça a fait ce que...
NG2 compares to NG1.
Yeah, I think NG1 was obviously our first mission. There was lots to learn, and we did learn a lot, and unbelievably successful in that we made our goal, which was to get to orbit. This time we're going to be a little bit more ambitious. We want to not only get to orbit, but we have our first paying customer this time with Escapade, and get them off to Mars. That's the first part of our goal, and then the second part of the goal is to land the booster out on Jacqueline. And if we don't, we have more over here in the factory that we're building, but we're going to give it our best shot.
Never Tell Me the Odds is pretty fitting for this booster. You know, we are taking our second attempt at landing it for the first time. How are you going to feel if we land it?
Well, I certainly will not channel my inner C-3PO. I will be very ecstatic. I will be on pins and needles up to that point, but it would be a huge achievement for the team and for Blue. I think that we have a good chance, but if we don't, like I said, we can build more, but I will be over the moon if it happens.
Now, New Glenn is obviously just one of the many systems we have here, right? We have New Shepard, we have Lunar, we have In-Space Systems. How are all of those organizations really working together to further our ultimate goals?
Yeah, I think each component of what we do has a piece of trying to get millions of people to work and live in space, and they all have their individual. But as it relates to this particular mission, a huge amount of people have put work into it. Obviously, our engines team in building both the engines for the booster, the BE4s, and the BE3Us for the upper stage. We also have a huge amount of work by the obviously New Glenn team building this vehicle, but also New Shepard has been a pathfinder. So all our avionics fly on New Shepard first, so that we can get a sense of what's going on there and get a sense what it's like to have flight-ready hardware. And so it takes a whole team, and it's a very
Alors,
big
vivement
cross-functional
le
effort across
lancement
Blue.
You know,
de
we have
Blue
more
Origin.
than 10,000
Ça va
employees
arriver dans
here
pas
that are
longtemps.
very excited about this moment. I'm one of them. What is your message to those who are going to be watching our webcast and be watching NG2 take to the skies?
Well, I think everybody will be a little bit on pins and needles, I'm sure, but I would say that this is a culmination of a lot of work from a lot of teams. It's not the end point of our journey. Obviously, we have a lot more rockets to make and a lot more customers to make happy as we move forward. But to the extent we're successful here, I hope everybody at Team Blue takes a pause, smiles a bit, celebrates, because it'll be a great achievement for us. And we'll take that deep breath. We'll sort of embrace the moment and then move on, because we have a lot of customers waiting for us to succeed. And there's nothing that makes you happier in business and in your life when you see the smile on customers' faces.
Did you ever think that you would be doing something like this in your career? No. When you're watching your rockets launch? No?
No, not in a million years. I was very happy making Fire TVs and Echoes, but it is a boyhood dream, and so to be able to have it, I kind of pinch myself every day and just amazed that I get to wake up and help this lead this amazing team of people build incredible technology like New Glenn.
I mean, in reference to that, one of the first things they ask you when you come onto Blue Origin is, what is your first memory of space? What is your first memory of space?
Yeah, I
have a lot of pictures. It turned out my third, fourth, and fifth birthday, I have these old Polaroids of the cake, and they all have rockets on it. I was enamored with rockets as a kid, and never took the path where I thought I'd be running a rocket or a rocket company, but it turns out that it was very early in my life that
Nous sommes bientôt à
And
l'heure
we're so
du
grateful to have you here
lancement.
at the helm. Dave, thank you so much for your time. I appreciate it.
Donc là, on avait la petite
And it was such a
explication
great interview to have a
entre
moment to sit down with our CEO and talk with him.
les,
If you are just tuning in, this
la
is
journaliste
the
et
launch
puis
of L
un membre de Blue Origin.
in G2. We are at L minus under 6 minutes, and we have to tell you
Il
guys,
n'y a plus de
right now
nuages,
we
ça
are
y est, c'est
tracking
dégagé.
the cruise ship that is in the area and closely tracking weather as we heard in the go poll. But my understanding is that by the time it comes to our moment of
Go
launch,
for
the
lunch
cruise
pour
ship should
l'instant.
be out of the way. We're still keeping our eyes on that weather, Ariane.
Absolutely. But with that, we're under 6 minutes to go. Let's go out to Eddie because you realize we're about 5 minutes to go from the launch. Eddie, how's everybody feeling out there?
Yeah, it is hype out here. We are so excited to be at less than 5 minutes before launch.
Ah,
We're excited to be here.
ils sont à fond là, le public.
On a chicken? A rooster?
Yeah, we got rooster, and the flag. Everybody say hi to rooster. Escapade, and this is the team that's launching the rocket today. They helped build
Alors,
it.
Amazing. They are absolutely psyched. And what we're waiting for here is a go, no go, a final go, no go. We're bringing this down
go, no go.
to the minute on this one. We want to launch before our window, so we're waiting on the team to determine if that's way to go.
Oh, Eddie, let's go blue. Let's go blue. Thank you so much. We are hyped. They are hyped. Since we are at
Nous sommes sur un
essentially
go
L
no go pour
minus
l'instant.
4 minutes, let's go ahead and toss it back over to the rocket right now.
Vous inquiétez pas, hein, nous sommes sur un go no go. Le lancement va bien avoir lieu. N'hésitez pas à mettre des likes, partagez le live, abonnez-vous si vous voulez plus de lancements comme celui-ci. Le lancement va bien avoir lieu. Bonjour à tous. Bonjour à tous. Bonsoir surtout. N'hésitez pas à vous abonner, partager le live. N'hésitez pas aussi à mettre des petits commentaires, poser des questions. du hold, bien sûr. Tout est go. Le lock c'est go, le LH2 est go. Weaver, check, c'est go. Tout est bon pour le lancement. Ah. Ah non, ce sera pas go. Terminé. C'est pas bon. Je crois que c'est pas bon signe. Scrub. On a mis scrub. Alors, que nous disent les journalistes?
Take to the skies today. We came down to the wire, and then there you have it. But my name is Tabitha Lipkin. This is Ariane Cornell. We're going to keep you guys posted and updated with all the information that we get as it becomes available to us. That will be on our social media. And until then, we look forward to seeing you at our next launch. And stay cool. Rodatum for Rossiter.
Ah. Nous sommes sur un report du coup de la mission, malheureusement, mais nous nous retrouverons bien sûr certainement demain. Je vous tiendrai au courant, mais en tout cas pour ce soir c'est un report complet de la mission. La mission est en scrub. Donc la fenêtre de tir était jusqu'à 22h12 et c'est terminé. Quant à moi, je vous souhaite une très très belle soirée. Reposez-vous bien. Et puis, en espérant à demain pour couvrir le lancement de la mission de Blue Origin. Escapade. très belle soirée à vous. Portez-vous bien.